Thank you for joining this lesson. We are going to do errors and approximations. Remember to subscribe to this channel and also to share the link with your friends. So we are taught to calculate the percentage error in the volume of a cone of radius 7.0 centimeters and height 20 centimeters. So for us to calculate percentage error, we should first of all know the limits of these dimensions. The accuracy of the radius is 1 decimal place, which means the absolute error in the calculation of this radius is when we take that accuracy and we divide it by 2. This gives us 0.05. So this means the radius of this cone is going to range between 7.0, that is, when we add or subtract the absolute error of 0.05. And this gives us a radius ranging between 6.95 up to 7.05. These are centimeters. We go again to the accuracy at which the height is recorded. It is to exactly the nearest whole number, which means we will take 1 and divide it by 2. This will give us 0.5. That means the height of this cone is going to range from 20 plus or minus 0.5. So this gives us height which is ranging between 19.5 up to 20.5. These are still centimeters. Therefore, now we have the limits of the dimensions. We can get to the calculation of volume now. We can start with actual volume. Volume, actual. So the actual volume is always given by a that times the base area of a cone, and the cone has a base which is circular. So the area of the base will be 22 out of 7. Radius which is 7.0. Then we square, multiplied by height which is 20. Therefore we can get the actual volume, or what we call the working volume. A third multiplied by 22 out of 7, multiplied by 7 squared, then multiplied by 20. This gives us a volume of exactly 1026.67. This is nearest to 2 decimal places, cubic centimeters. From there we can get the maximum volume, whereby we shall use again a third times base area 22 out of 7 multiplied by the maximum radius squared. So the maximum radius is going to be 7.05. Then we square this figure, multiplied by the maximum height, which is 20.5 centimeters. So we use again the calculator, whereby we will have a third multiplied by 22 over 7 multiplied by 7.05 squared multiplied by 20.5. So this will give us a volume which is equal to 1067.42. Again, cubic centimeters. Then finally, we can have volume, the minimum, which will be again a third multiplied by 22 out of 7 multiplied by, because we're getting volume minimum, then we use the minimum radius, which is 6.95, and we square, multiplied by the minimum height. Minimum height is going to be 19.5. And we compute again using the calculator. So a third multiplied by 22 out of 7 multiplied by 6.95 squared multiplied by 19.5. This will give us 986.75 cubic centimeters. So we have actual volume, we have the maximum volume and the minimum volume. After getting all the types of volumes, now we get to what we call absolute volume, or absolute error in the volume, which is given by volume maximum minus volume minimum, then divided by 2. So this means we'll get the maximum volume 1067.42 minus 986.75. Then we divide by 2. This is going to give us, we take 1067.42 minus 986.75. Then we divide by 2. We get 40.335. That is the absolute error. There is another error called the relative error, which is given by absolute error divided by the actual value. So you get absolute error 335 divided by actual volume, which is 1026.67. So this is going to give us 1026.67. This will give us 0.03928. Now we get what we call percentage error by multiplying relative error with 100. And this gives us 3.929, correct to 4 significant figures, percent. So that is the percentage error in the calculation of the volume of a cone with the given dimensions. Thank you for following. Subscribe and share the link with your friends.